Before we dive deeper into warehouse processes and systems, it's essential that you become familiar with the core terminology used in intralogistics. Understanding the language of the field is a prerequisite for understanding the concepts, the technologies, and the decisions that are made every day in warehouse operations. To help with this, I've selected a stock photo of a typical warehouse. While it may seem like a simple image at first glance, it actually contains a wealth of detail. In fact, this single photo offers a surprisingly rich basis for discussion because it illustrates many of the key components and pieces of equipment that are commonly found in real-world warehouse environments. We'll use it as a visual reference to walk through some of the most important structural and operational elements that make up a modern warehouse. As we examine this image, you'll begin to see just how much thought goes into the design and layout of a warehouse. Every element has a purpose, and every detail supports some part of the broader material flow. From the racking systems to the floor markings, from the fire safety installations to the picking locations, nothing is random. Of course, it would be entirely possible to spend hours analyzing just this one photo. And in some ways, that's exactly what we will do, although not all at once. We will return to several of the components visible here at various points throughout the course, each time with a different focus depending on the topic at hand. For example, when we talk about storage strategies, we will revisit the racking layout. When we cover workplace safety, we'll look at aisle widths, protective barriers, and fire doors. When we get into inventory management, we will talk about how buffer areas and staging zones influence flow and throughput. So consider this image not just as an illustration, but as a kind of map. One we will explore and revisit from multiple angles as the course progresses. By the end of the course, my goal is for you to be able to look at a warehouse, whether in a photo or in real life, and instantly understand what you're seeing, how it works, and why it is designed the way it is. Let's begin our journey through this image by identifying and naming the most prominent features. Once you are familiar with the basic terminology, we can start to build upon it with more advanced concepts. Let's begin with the truck gates visible on the right-hand side of the photo. Truck gates serve as the interface between the warehouse and transportation vehicles. These gates are used for loading and unloading goods, making them a critical component of the warehouse layout. Nearly every warehouse designed to receive goods delivered by trucks or from which goods are picked up by trucks is equipped with such gates. So far, no surprises, but have you ever considered how many of these truck gates you actually need? When planning the number of truck gates, several factors must be considered. If you have any background in transportation, or if you are a truck driver yourself, some of our students have worked or currently work as commercial drivers. You know that waiting at a warehouse for your turn is not a truck driver's favorite activity. A truck driver may need to visit multiple warehouses in a single day, sometimes with fixed time slots booked at each location. Drivers also have lives outside of work and would likely prefer to be home for dinner at a reasonable hour. For us as logistics engineers planning the warehouse, this means we need to dimension the number of gates such that truck waiting times do not escalate. How do we achieve this? One option is to increase the number of truck gates. A better option, however, is to schedule truck arrivals so that they are more evenly distributed throughout the day. Increasing the number of truck gates comes with certain side effects. First, you need a wall long enough to accommodate all the gates, which may constrain the shape of the building you can buy or build. There are often additional constraints, such as the size of the land lot or the need to position gates in specific areas to reduce noise for nearby residents or because of the location of roads. Another issue is that having many gates open simultaneously can create challenges for air conditioning or heating the warehouse. Additionally, you will need sufficient warehouse staff to handle tasks such as checking paperwork, supervising the unloading process, and signing off deliveries. For these reasons, it is much preferable to schedule truck arrivals and keep the number of gates to a minimum. But how low should that number be? That's something you'll need to determine. You can approach the problem using deterministic calculations, queuing models, or simulations, methods you may remember from your operations management course. Another question related to the gates is whether they are used for both goods in and goods out, or only one of these. Will the goods in gates be on one side of the building and the goods out gates on the other? Will there be separate gates for different sections of the warehouse, such as a deep freeze area? Constraints may limit your options, but if you can decide freely, the position of the gates will likely depend on the material flow direction inside the warehouse. For example, the material flow could be linear, with goods entering on one side of the warehouse and exiting on the other. Alternatively, it could be U-shaped, with goods in and goods out processed on the same side of the warehouse. This discussion of gates brings us to the next point, the space in front of the gates. You may notice there is some space between the pallet racks on the left side and the gates on the right side. What is this space for, and how much of it should there be? Let's address the first question first. What is the space good for? First of all, this depends on whether these are goods in gates or goods out gates. If these are goods in gates, meaning gates for incoming goods, then we need some space just before the gates for the truck drivers to unload their trucks. Almost never do you bring goods delivered to a warehouse directly to their final storage locations. Instead, you unload the pallets, roller cages, or cartons, and warehouse staff register the arrival of the goods. There may also be checks for the completeness of the delivery or quality checks before the goods are brought to the storage or picking locations in the warehouse. If something goes wrong, for instance, if there is deviation in the quantity from what was ordered, or the quality of the goods is such that they cannot be used to fulfill customer orders, it is crucial to notice this as soon as possible. This helps avoid interruptions during the picking process, the manufacturing process, if the goods are supplied to a production line, or even later at the customer site, where complaints could damage your reputation. This means that in front of each gate, you need sufficient space to unload all the goods from a truck, check them, and register them before they are moved to their storage or picking locations. If these are goods out gates, then we need space in front of the gates to buffer the goods that will leave the warehouse through a particular gate. All pallets ready for shipping will be lined up in front of the gate through which they are loaded onto the truck. This reduces the time the truck driver needs to load the truck. The less time the driver spends loading, the sooner they can leave the gate and make it available for the next truck, reducing the number of gates needed for smooth operations. In other words, by buffering the goods to be loaded in front of the gates, we reduce the truck's turnaround time. You can compare this to airplanes being turned around at airport gates. Time at the gate is very expensive for airlines. Accordingly, airplanes do not wait for passengers. Passengers are expected to wait for the airplane. And so, travelers queue up at the boarding gate before boarding starts to minimize delays and ground time. An airplane would not normally wait for passengers who are late, but a truck might wait for a pallet that isn't ready for shipping. That's a key difference. Besides that, the analogy is quite suitable. Buffer space in front of the gates also has additional advantages. Pallets that have been picked and are ready for shipping need to be placed somewhere, while you could put them back into pallet racks in the warehouse. This would require picking them up again later for truck loading. To avoid this double handling, it is more efficient to place them where they will ultimately need to go, so the truck driver can pick them up. And no, you do not want the truck driver to go through your warehouse to pick up the pallet themselves. This takes too much time, and as we've discussed, time is of the essence. You want the truck to leave as quickly as possible. Additionally, this is a safety and insurance concern. The truck driver may not have received safety instructions for the warehouse or even be part of your organization. You need to ensure there are no accidents and that goods do not go missing. I am not implying that truck drivers are untrustworthy, but not all truck drivers are trustworthy. In general, you want to avoid any risks or hassles related to theft or the potential for it. Let's now take a closer look at the R in front of the truck gates. In our example, we don't know whether it's goods in, goods out, or both. While this space is often physically modest compared to storage or picking zones, it plays a central role in the flow and stability of warehouse operations. In fact, any inefficiency or error in the goods in process can ripple downstream, and any error in the goods out process renders all the efforts upstream pointless. Let's first talk about goods in. The goods in area is the physical entry point for incoming deliveries. This is where pallets, containers, cartons, or individual items arrive at the warehouse, usually by truck, and are unloaded, inspected, registered into the warehouse management system, and often temporarily staged for further processing. Because this area links the outside world with internal processes, it acts as a buffer zone between external variability and internal structure. Operationally, several tasks converge here. First, the receipt of goods must be confirmed. That typically involves scanning barcodes or RFID tags to verify delivery quantities against advanced shipping notices or purchase orders. Damaged or missing items are noted, and in many cases, goods are quality checked on the spot. This ensures that defective or incorrect deliveries are identified early and do not contaminate internal inventories. Once received, goods may be directly transferred to storage or cross-docked for immediate reallocation. From a design perspective, the goods in area must be both flexible and robust. It should offer enough space to accommodate varying shipment sizes, different unit loads, and a certain degree of temporal misalignment between truck arrivals and internal resource availability. A common planning mistake is to undersize this area based on average throughput, which may lead to congestion during peak delivery times. If the staging area overflows, this can block unloading docks, delay put-away, or even force trucks to wait outside, potentially disrupting delivery schedules. The layout of the goods-in zone must also support efficient material flow. Ideally, paths are short, cross-traffic is minimized, and temporary buffers are clearly marked. Depending on the operation, the zone may also contain dedicated areas for repackaging, labeling, or quality control. In automated or semi-automated facilities, the goods-in area might be directly linked to conveyor lines or shuttle systems feeding into high bay storage. From a safety perspective, this area requires special attention. Trucks, forklifts, pallet jacks, and pedestrians are often operating in close proximity. Proper lighting, floor markings, and traffic rules help reduce the risk of accidents. Additionally, the temperature and humidity in this area can be critical, especially when receiving temperature-sensitive goods. The goods-in process also plays a crucial role in data integrity. If goods are not registered correctly, if quantities, locations, or item IDs are entered inaccurately, the resulting errors may go undetected until later stages of order picking or inventory counts. That's why many modern warehouses rely on digital tools and real-time integration with ERP or WMS platforms at this stage. The accuracy of the initial check-in often determines the reliability of the entire system. What if that's a goods out area? The goods out area is also known as the outbound or dispatch zone. This section of the warehouse represents the final step in internal material flow, before products leave the facility and enter the outbound leg of the supply network. While often overlooked in favor of storage and picking systems, the goods out area is critical to ensuring that orders are shipped correctly, on time, and in good condition. Functionally, this zone acts as the consolidation and handover point for all outgoing deliveries. After items have been picked, packed, and labeled, they are transferred here for final preparation. Depending on the operation, this may involve sorting shipments by carrier, route, or customer. It may also include pallet wrapping, loading sequence coordination, and generating shipping documents such as delivery notes, labels, or customs forms. One important task in this area is load sequencing. It's not just about moving goods out of the building. It's about loading them in the right order. For example, delivery routes may involve multiple stops, which means that pallets must be loaded in reverse delivery order. Buffer space is another key consideration. The goods out area must be large enough to accommodate multiple shipments being prepared in parallel, while still allowing for clear and safe movement of goods. If the space is undersized, outbound pallets may block access routes or encroach on packing or picking zones, leading to confusion and safety hazards. As with the goods in area, it's a common planning mistake to size the dispatch zone based on average volumes rather than peak outbound activity. From a safety and ergonomics perspective, this area must accommodate a mix of manual and mechanized operations. Forklifts, pallet jacks, conveyor belts, and, in some cases, automated guided vehicles, AGVs, all operate in close proximity. Since goods are often staged here temporarily before loading, clear zoning and floor markings help avoid misplacements and collisions. The pressure to load quickly should not come at the expense of proper handling or safety protocols. Technology also plays a central role. Barcode scanning and shipment validation systems help ensure that the right goods are loaded onto the right vehicle. Many warehouses now use transport management systems, TMS, or integrated WMS modules to coordinate dispatch activities in real time, including dock scheduling and load tracking. This not only increases efficiency, but also improves transparency toward customers and logistics partners. An additional challenge in this area is dealing with load variability. Like inbound flows, outbound orders may vary significantly by day or even hour. The goods out process must be flexible enough to accommodate express shipments, partial loads, and different transportation modes, from parcel couriers to full truckloads or even containerized freight. Let's move on to the next element on this slide. The pallet racks on the left. Single deep pallet racks are one of the most commonly used storage systems in warehouses. These racks are designed to store pallets in a single row, allowing for easy access and retrieval. This design is particularly efficient for fast-moving items or products that require frequent handling, the reason being that you can access any pallet at any time. But it quite simply is also the standard way of storing pallets in racks. On this picture, you can see pallet racks standing back to back to reduce the warehouse space needed. In other situations, they might stand at a wall. A key advantage of single deep pallet racks is their simplicity. They provide high visibility and accessibility to inventory, making them ideal for operations where first in, first out, FIFO inventory management is required. However, they also have limitations, such as lower storage density compared to double deep or flow racks. When designing these racks, it is important to consider factors like load capacity, the type of forklift used, and the overall warehouse layout. Additionally, deflection, or the bending of the beams under heavy loads, must be monitored. We'll discuss deflection in more detail later. Talking about pallet racks. Let's take a closer look at how they are structured. You'll often hear people referring to different parts of a rack using specific terminology, and it's important to get familiar with that early on. One of the fundamental structural elements in racking systems is the bay. A bay is the vertical section of a rack structure. You can think of it as one slice of the rack system framed by two upright supports and containing multiple storage levels. In very simple storage systems, you might find racks with just a single bay, but in larger and more typical warehouse setups, racks are composed of multiple bays that are physically connected. These connections provide not only additional storage capacity, but also structural stability. By anchoring several bays together, the entire rack structure becomes more robust and capable of withstanding dynamic forces. For example, when pallets are loaded or retrieved by forklift trucks. Within each bay, you find what are typically called compartments. A compartment is one horizontal level or shelf within a bay. And depending on the rack configuration, it usually contains 2, 3, or even 4 individual pallet positions side by side. These compartments are supported by beams, usually painted in a distinctive color like orange or yellow, that run across the width of the bay and bear the load of the pallets placed on them. In practice, each pallet location within a compartment is treated as a unique storage position. In well-managed warehouses, every pallet location is clearly labeled with a unique identifier. This is not just helpful, it's essential for efficient warehouse operations. The naming convention of pallet locations typically follows a hierarchical structure incorporating 4 levels of detail: the row in which the rack is located, the bay number within that row, the compartment level or height, and the specific position within that compartment, say left, center, or right. Let's say you're working with row 03, bay 07, level 2, and the leftmost position in that compartment. The full location code might read something like 03-07-02-L. This systematic coding helps warehouse staff quickly find or assign storage positions, and it also enables integration with digital warehouse management systems. Beyond identification, the structure of bays and compartments also has implications for safety, efficiency, and even ergonomics. For example, lower compartments are more accessible for manual picking, while upper compartments might be reserved for bulk storage or accessed only with forklift trucks. In high bay systems, upper compartments might be entirely automated, serviced by stacker cranes or shuttle systems. Understanding the layout and terminology of bays and compartments is not just academic. It's fundamental to how inventory is stored, retrieved, and managed in any warehouse. And as we'll see later, these structural elements also play a key role in how we optimize storage density, plan picking routes, and manage replenishment processes. Let's talk about what's stored in the racks. Although we can't be sure, since what we're looking at is just a stock photo, the pallets that are stored in the racks look very much like Euro pallets. There are many different types of pallets on the market, but wooden Euro pallets probably are the most common type of pallets in Europe, as you might have guessed, because of their name. Also, what we're seeing is that these pallets are stored in the racks short side leading. Euro pallets are 1,200 millimeters long, 800 millimeters wide, and 144 millimeters high. We can see that they are placed in the rack with the short side pointing towards the warehouse aisles. This makes sense since the short sides have openings between the blocks, and we can use these openings to pick up pallets more easily with the forks of a forklift truck. Storing pallets short side leading reduces the length of the warehouse aisles. Storing pallets short side leading has one important disadvantage, however. Let's now take a closer look at one of the most critical functional aspects of warehouse operations, the picking positions. We'll return to that point about pallet orientation shortly. But first, let's consider the role of the racking system visible in the picture. At first glance, all those pallet rack bays might appear to serve the same function, namely long-term storage. And while that is certainly part of their role, there is often more to it. In many warehouse environments, a number of these racking positions are also designated as picking locations. In other words, they are not just passive storage positions, they are dynamic access points from which goods are retrieved to fulfill customer or production orders. The degree to which rack locations are used for picking varies by warehouse type and operational strategy. In some cases, every single position may serve as a potential picking location, particularly in environments where goods are picked directly from pallets or where storage density is low. In other facilities, especially those employing zoning or forward picking strategies, only a subset of the available locations is used for picking, while the remainder is reserved for overstock or reserve inventory. Now, not all locations are equally suitable for picking, especially when the process is manual. A person walking through the aisle, possibly pushing a picking cart or operating a hand scanner, must be able to access the stored goods without the aid of additional equipment, such as a forklift or ladder. As a rule of thumb, the most efficient picking occurs at locations that are accessible from ground level, ideally between waist and chest height. This height range minimizes physical strain on the picker and allows for quick, safe, and efficient retrieval of items. These ergonomically favorable zones are sometimes referred to as the golden zone in warehouse design literature. Conversely, locations near the floor or high up in the racks are typically less favorable. Picking from the lowest positions requires repeated bending or squatting, which can lead to fatigue or even injury over time. Upper locations, on the other hand, may require mechanical assistance or lifting tools, which slows down the process and introduces safety risks if not handled properly. In most cases, fast-moving items, those that are picked frequently or in large quantities, are strategically placed in these easy-to-reach golden zone positions. Slower-moving stock, or items that are bulky but light, may be allocated to less accessible locations. In more advanced systems, this allocation is dynamically managed using warehouse management software, WMS, that monitors pick frequency and recommends or automates slotting decisions. Now, coming back to the earlier remark about pallet orientation. Storing pallets short-side leading, while beneficial in terms of structural stability and forklift handling, makes it more difficult for a picker to access individual cartons on a pallet. With the short side facing the aisle, there is less exposure to the goods, which can complicate partial picking, particularly for large or shrink-wrapped loads. This limitation can be mitigated through operational practices, such as partially depalletizing certain items in advance, or through the use of customized racking that allows better access from the aisle side. The topic of picking optimization goes far beyond location and orientation. It touches on product characteristics, order profiles, batching strategies, pick path planning, and even human factors engineering. For instance, some warehouses apply A/B/C analysis to determine which products should be stored in the most favorable picking positions based on historical pick frequency or turnover rate. Others may use real-time data to constantly update and reallocate picking positions based on seasonality, promotional activity, or demand shifts. Because order picking is one of the most labor-intensive and costly processes in any warehouse, often accounting for 50% or more of the total operational costs. It receives significant attention in both research and practice. Picking performance can determine whether a warehouse operation is merely functional or genuinely profitable. This is why so much effort is placed on optimizing every detail of the picking process, from physical layout to information flow to employee training. In this course, we'll revisit several of these aspects in more detail. For now, just keep in mind that the location and accessibility of goods within the rack is not a matter of chance. It's the result of deliberate designed choices aimed at maximizing productivity, minimizing physical effort, and ensuring a safe and efficient working environment. Just before the entry to the other section of the warehouse in the upper right corner, you can see a forklift truck. More specifically, we are looking at a reach mast truck. Reach mast trucks are specialized forklift trucks designed for narrow aisles and high racks. These trucks are equipped with extendable masts that allow them to reach pallets stored at significant heights. You can see that the aisles between the racks are not very wide. There are forklift truck types that wouldn't be able to operate in these aisles. Reach mast trucks can. This is one of the most important build types of forklift trucks for warehouses, and we'll discuss reach mast trucks later in greater details and contrast them with other types of forklift trucks like counterbalance trucks and VNA trucks. With this reach mast truck you see on the photo, all the upper pallet locations in the rack can be accessed. Talking about the upper location. Let's now turn our attention to the height of the warehouse. Specifically, what is often referred to as the clear height, that is, the usable vertical space within a building, measured from the finished floor to the lowest obstruction, such as lighting, ductwork, or the bottom of a structural beam. While we can't determine the exact height of the warehouse in the photo, it appears to fall somewhere between 8 and 11 meters. This range is quite typical for conventional warehouses designed to be operated with reach trucks or similar equipment. In many cases, 11 meters of clear height has become something of an industry standard, as it allows for 3 to 5 levels of pallet racking while still keeping the top levels accessible to manual equipment without the need for automation. The decision on how tall a warehouse should be is far from trivial. It has wide-ranging implications for almost every aspect of warehouse design and operation. First and foremost, it affects the footprint of the building. If you increase the clear height of the facility, you can store more pallets vertically and thus reduce the amount of land or floor area you need. This is particularly relevant in urban or industrial areas where land is scarce or expensive. However, the benefits of increased vertical space come with certain trade-offs. Once a warehouse exceeds conventional reach truck limits, typically around 11 to 12 meters, standard manual equipment is no longer sufficient. At that point, companies must consider alternative technologies, such as very narrow aisle, VNA, trucks, order picking cranes, or automated storage and retrieval systems, ASRS. These solutions can efficiently utilize the additional height, but are considerably more expensive, both in terms of initial capital investment and ongoing maintenance. Fire safety is another critical consideration. As the height of the warehouse increases, fire protection requirements become more demanding. Most notably, high bay warehouses usually require sprinkler systems capable of delivering water at higher pressures and over greater distances. Installing these systems can be costly, and even when they function properly, they carry a risk of collateral damage. A false activation or a localized system failure can result in water damage to stored goods. In facilities storing electronics, paper products, or consumer goods, this risk is particularly serious. Ventilation and climate control are also influenced by the building's height. The higher the structure, the more air volume there is to heat, cool, or circulate. This doesn't just affect energy costs, it also influences the consistency of temperature and humidity levels across vertical zones. For example, in the summer months, the upper parts of the warehouse can become significantly warmer than ground level, which may be problematic in climate-sensitive environments. Furthermore, the height of the warehouse determines the type and configuration of racking systems. In mid-height warehouses, say around 10 to 12 meters, it's feasible to use static pallet racks operated by forklifts. However, once buildings exceed 15 to 20 meters, automation becomes not just more efficient, but often necessary. SRS systems, stacker cranes, or shuttle systems are typically deployed in such environments to ensure safe, accurate, and high-throughput handling of goods stored at significant heights. That said, it is important to match building height not only to the equipment, but also to the operation profile of the warehouse. A fast-moving e-commerce facility may prioritize throughput and access over pure storage density, in which case ultra-high racking may actually slow down order picking. Conversely, a bulk storage operation with infrequent access to stored items may benefit greatly from high bay configurations. On the photo, you see not only a reach mast truck, but also a much simpler vehicle for pallet transportation, a pallet jack. These manual or electric devices allow workers to lift and transport pallets with ease. They consist of a handle, a hydraulic pump, and two forks that slide under the pallet. When the handle is pumped, the hydraulic system raises the pallet slightly off the ground, making it easy to move. Pallet jacks are particularly useful for short-distance transportation in small or medium-sized warehouses. They can maneuver in tight spaces where forklifts might struggle, such as narrow aisles or crowded staging areas. Additionally, they are a cheap alternative to motorized equipment for operations that don't require high-speed movement or heavy or high lifting. If you have worked in a warehouse or even in a supermarket before, you have probably worked with a pallet jack. They are very common. Let's take a closer look at the yellow demarcations you can see on the floor directly in front of the pallet racks. These marked areas designate what we refer to as buffer or transfer positions. At first glance, they may seem trivial and just another bit of floor marking, but they serve a critical role in coordinating movement between different stages of warehouse operations. A buffer or transfer position is essentially a temporary holding spot for a pallet. It functions as an interface between two material handling processes, especially when these processes are carried out by different types of equipment or personnel. Consider, for example, an operator using a manual pallet jack. This type of equipment is suitable for horizontal transport, but cannot lift loads to the vertical height required to access rack storage. When this operator needs to deliver a pallet to be stored in the racking system, he brings it to a designated transfer position and leaves it there. From this point, the responsibility for the pallet is effectively handed over to another operator, typically one driving a forklift truck with vertical reach capabilities, who retrieves the pallet from the buffer zone and stores it in the appropriate racking location. This interface also works in the opposite direction. A forklift driver may retrieve a pallet from a high rack location and place it in a transfer position, from where it is collected by a pallet jack operator and brought to its next destination, perhaps a packing station, a staging area, or a consolidation zone. What makes these transfer positions particularly important is their function in decoupling process steps. Rather than requiring both operators to be available at exactly the same time, the buffer allows for asynchronous operation. One operator can complete their task independently of the other. This improves flexibility and process flow, especially in busy warehouse environments where not all equipment is always immediately available. In that sense, buffer positions add a degree of temporal separation that contributes to smoother, more continuous operations. From an operational perspective, these positions must be clearly marked, well maintained, and consistently used according to predefined rules. Otherwise, they can easily become ad hoc storage zones, leading to confusion or even safety hazards. When used correctly, buffer positions help create a more structured handoff between different systems or process steps. In more advanced systems, these transfer positions can be digitized or integrated with the warehouse management system. This means the system can register the pallet as having arrived at a certain transfer point, triggering a task for the next operator. In this way, buffer positions also become logical handover points in the digital workflow. It's worth noting that buffer positions are not limited to human-operated processes. In automated warehouses, similar principles apply. A conveyor might deliver a tote to a transfer station, where it waits for a robotic arm or a shuttle to pick it up. Even here, the buffer serves the same purpose. Decoupling two processes and ensuring that small timing mismatches do not interrupt the flow of goods. Earlier, I mentioned the concept of deflection. A clear example can be seen in the pallet shown in the image. You can easily observe how it bends in the middle under the weight of the load. Technically speaking, some degree of deflection is always present when a pallet is under load. This is entirely normal and acceptable, as long as the deformation remains within defined tolerances. These tolerances are typically specified by pallet manufacturers, rack designers, or occupational safety standards. In the example we're looking at, however, the deformation seems to be approaching, or possibly even exceeding, those tolerances. Why is this important? Excessive deflection can lead to both safety hazards and operational inefficiencies. In the worst-case scenario, a pallet under too much stress might break. If that happens, the load could fall off and drop from the rack, potentially causing product damage, destruction of warehouse infrastructure, or even personal injury. This risk becomes especially critical in high bay warehouses, where items may fall from heights of 12 to 18 meters. Even without a complete collapse, a pallet that deforms too much may no longer function properly in automated environments. Many conveyor systems and automated storage and retrieval systems rely on strict dimensional accuracy. A sagging pallet can jam, misalign, or be rejected by the system entirely. In addition to that, excessive deflection can compromise vertical clearance between racking levels, which is particularly problematic in dense storage environments with little room for error. There are several reasons why a pallet might deflect excessively. One key factor is how the load is distributed. If heavy items are concentrated in the center of the pallet rather than evenly across its surface, the bending stress will increase significantly. Another important factor is the material and design of the pallet. Wooden pallets are quite robust and can carry heavy loads, but they may weaken over time with repeated use. Plastic pallets behave differently. They are generally more resistant to sudden breakage, but they tend to deform permanently under sustained pressure, especially if overloaded or exposed to high temperatures. Some specialized pallets are made of metal, which can reduce deflection but are heavier, more expensive, and less common in standard warehouse operations. Finally, deflection depends on how the pallet is supported. If it rests only on two beams at the front and back, the unsupported span in the middle can become a weak point. Additional support, such as crossbars or full decking panels, helps distribute the weight more evenly and reduce sagging. From an engineering perspective, deflection is a classical beam bending problem. The amount of bending is influenced by the length of the unsupported span, the magnitude and position of the load, and the stiffness of the pallet's materials. Structural parameters, such as the modulus of elasticity and the moment of inertia, determine how much a pallet will deform under a given load. Fortunately, there are several practical ways to mitigate the risk of excessive deflection. First, it's important to load pallets correctly by placing heavy items near the corners or edges rather than concentrating them in the middle. Second, facilities can install additional support structures in the racking system, such as central support bars or wire mesh decking, to reduce the span over which the pallet is unsupported. Third, the type of pallet selected should match the load and racking conditions. It's important to note that the rated racking load of a pallet is not the same as its static or dynamic load capacity. Only pallets explicitly rated for racking should be used without additional support. And finally, pallets should be inspected regularly. Over time, even high-quality pallets degrade, especially if they are reused frequently or exposed to harsh environments. Damaged or deformed pallets should be removed from circulation to prevent accidents and maintain system reliability. In summary, pallet deflection is not merely a question of structural mechanics. It has far-reaching implications for warehouse safety, automation compatibility, and operational efficiency. It is a risk that is often underestimated, but one that can be effectively managed through proper design, handling, and maintenance. By proactively addressing the issue, warehouse operators can ensure both safer and more efficient operations. On the right-hand side next to the gate, you see a fire hose. The primary purpose of fire hoses is to provide a means for immediate firefighting action in the event of a fire outbreak, either by trained staff or, in some cases, by emergency responders who arrive on site. They serve as a first line of defense, especially in the time between the detection of a fire and the arrival of the fire brigade. Even though automatic sprinkler systems are often installed in modern warehouses, manual firefighting equipment like hoses remains a critical redundancy. The hoses themselves are typically connected to the building's internal water supply and are designed to be long enough to reach deep into the storage and working areas. Let's now turn our attention to another critically important element of warehouse safety and design: fire doors. These doors are not simply a regulatory requirement. They play a vital role in protecting both people and assets by limiting the spread of fire, smoke, and heat in the event of an emergency. Fire doors are specially designed and certified doors that separate fire compartments. Their primary purpose is to contain a fire within one section of the warehouse, preventing it from spreading rapidly to adjacent areas. These doors are typically constructed from fire-resistant materials, such as steel, and they are tested and classified according to how long they can withstand fire, commonly 30, 60, or 90 minutes. From a functional perspective, fire doors must strike a balance between safety and usability. In day-to-day operations, they are often left open to allow for the smooth movement of people, pallets, and equipment. However, they are typically equipped with sensors or fusible links that automatically close the door in the event of a fire alarm or elevated temperatures. In some cases, they are connected to the building's fire alarm and suppression systems to ensure synchronized responses. Some fire doors are even motorized and integrated into conveyor systems. These versions are designed to close around the conveyor path, or to include a shut-off gate that halts the movement of goods through fire zones. It is essential to understand that fire doors are only effective if they are correctly installed, maintained, and kept unobstructed. A fire door that is propped open with a pallet or blocked by equipment is not just useless, it becomes a liability. Regular inspections, typically conducted as part of facility safety audits, are necessary to ensure that the doors close properly the seals are intact, and the control systems function as intended. More than once I have found fire doors blocked by pallets left in the way for temporary storage, which should never happen. If a fire door can't close because it's obstructed and the entire warehouse burns down because the fire could not be contained, your fire insurance has very good reason to withhold payment.